So thank you everyone for coming to our Innovative Discovery series. Today we have a fascinating topic. Dr. Duncan will reveal to us the keys to success in publishing and funding, and she will talk about empathy in scientific communication. So before I introduce our speaker, let me go over some housekeeping issues. For CME credits, you must now text the CME office to receive credits. The activity ID is 218. And this is both for both online and in-person viewers. And they are handouts by the sign-in sheet. Make sure you sign in and please RSVP so we can better prepare for the next session. Next week, we have a tech talk on Thursday with Dr. Zhang from UD speaking on functional data analysis. Then an ID series presentation on Friday when Dr. Congenital from the University of Tennessee will speak on dynamic abandon and extract decisions for failed cardiac device leads. And also the next tech talk will be a brown bag. So that's next Thursday. And the week after that is Health Literacy Week, and we will have two speakers from Sutter Health visiting to talk about patient understanding and health management. Please see the full schedule on the ACCEL website and grab a copy of the new fall schedule in the back of the room. And all the previous presentations are available on our website, DE-CTR.org, and it's very easy to access them. So we are really delighted to have Dr. Duncan with us today. Dr. Duncan is full professor in the Department of Biological Sciences at University of Delaware. She obtained a PhD in biochemistry from Rutgers and the State University of New Jersey. And she was also the graduate program director of the Department of Biological Sciences. And she's also a guest professor right now in Central South University in Changsha in China. This is very impressive. She has all kinds of titles and honors. She is a member of the Board of Trustees of the Association for Research in Vision and Ophthalmology, and she also leads the training in grantsmanship for the mentoring and education core for the ACCEL, for our ACCEL-CTR. She has had multiple awards and has been extensively funded by NIH and foundations for her research, and has also received multiple educational grants to train graduate students. She has mentored numerous students, postdoctorate fellows, and faculty, has also several patents for cell lines and monoclonal antibodies and multiple peer-reviewed publications. And I'd like to know how you do all this because I am so impressed. That is very important. So thank you so much for giving this presentation.
So I'd like to thank you very much for the very kind introduction. Now, when I was asked to speak here today, we were talking about various topics. Now, most of what I do all day is that I study blinding ocular diseases, largely cataract, but I also have a research program looking at retinal detachments and other types of ocular conditions. So some of the examples that I might be giving you as I go through my talk might be very, very eye research specific, but hopefully that you'll see ways that this information can directly apply to you. Now, when we were talking about what I should give my talk on, the idea was to make this something that could be as broadly applicable. And one of the reasons that I chose this topic of empathy and scientific communication is that in my other job as training graduate students, one of the things that I find being a key feature about why scientific writing fails is not engaging, and sometimes that good science does not sound like good science, is because of an inability to get into the mind of the reader, to really empathize with what they're seeing and what they're going to be excited about. So as healthcare professionals, the whole concept of empathy is something that you have probably been talked to about somewhere or another in your training. There are numerous studies that patient satisfaction with doctors is very, very dependent on how much empathy they feel from their doctor. However, let's see, now that I don't know how to run this. Okay, so I did not actually get trained on how to use the mouse here. Oh, I don't know how to work your thing.
Maybe just the arrow keys.
That's not the thing either. Oh, sorry. This is what I get for not playing with the technology ahead of time. Okay. Okay. All right. All right. And so there are, but empathy some people would say that what I'm going to speak to you today is not empathy, but I would argue that there are many types of empathy, and people who really study this do define many subclasses. And the type of empathy most people think about is emotional empathy, and that's the power of entering into another's personality and experiencing their experiences. While that could be helpful, that's not really what I'm talking about. Similarly, I'm not talking about compassion and empathy, which is probably the type of empathy that is most useful in a healthcare setting, where you're aware of what the person you're talking to is feeling, and you have the ability to understand where they're coming from and listen to try to help them with their problems. What I am talking about here is cognitive empathy, and that's the ability to understand someone's thoughts and point of view in a rational sense. And this is basically being able to say that I am producing a piece of writing, whether that be a patient information brochure or a scientific paper or a grant, and I understand who's likely to read this, and I present the information in such a way that the reader can connect with that as effectively as possible. And this is also just the whole idea of knowing one's audience. Now, why does this matter so much? And it's one thing that I will say in my experience, people are very, very resistant to changing their writing and their presentation based on their audience. But the reason this is really, really important is that to get a paper into the most prestigious journals, they're going to be publishing work that is as broadly interesting and applicable to the largest audience as possible. That means that you have to make your work appeal or see why it's important to somebody other than somebody like yourself or even to yourself. In grants, it's also critically important. One thing that people, when they're applying for grants, don't really realize, unless you've served on a lot of grant review panels, is that the vast majority of grants actually propose to do pretty good science. You're not competing against bad grants. You're competing largely against good grants. However, there's not money to fund everything, which means the vast majority of grants that are submitted are not funded. So you have to be able to show yourself in the crowd of good scientific investigations. And how you do that is that you find a way to excite the people who are going to evaluate your grant. And the only real way to do that is to get out of your own head. You're already excited, but the people you're presenting to will not have that amount of time invested in your particular topic. So you have to figure out how to excite that reader. And so in the end, you have to understand what your reader will think is important and convince them that your work falls into that category of importance. Now, one of the things that when people are thinking about what they're writing, what I find is especially early career writers, the first thing that they don't really understand is that you're not writing for yourself. You're writing for a larger community. Now, usually the first thing I can get an early career writer to do is to start thinking of what the literature calls an interpretive community. These are the people with the exact same training, experience, and practice. They're the people with the common experiences to yourself. And they have the same norms, and they use the same jargon as you do. However, the thing about this is that most people, when they start, are dealing with an interpretive community of one. That's themselves. And they think it's clear because I understand it, but they're not able to step back and see what their interpretive community, the people who are evaluating this work, are going to be able to say. Now, at the first step, you are looking at people with the same experiences. However, the longer you write, you're going to have a much larger group that you have to appeal to, and you need to be able to communicate across a much larger community. Now, I just want to bring this up because this is I'm actually working on a project related to this right now. And this is at a very simplistic level, and that is collaborating and communicating outside of your area of expertise. Now, I am trained as a basic scientist. I have been studying eyes for the past 30 years, but I am not a trained clinician. And I took on a collaboration recently with a clinician who is an incredibly, incredibly talented surgeon. And we're studying this very, very fibrotic condition that occurs in people with a very, very rare genetic disease. And when he speaks to me, he is speaking in medical jargon to me. That he's telling me about symptomologies or clinical presentations, and I actually have to look up what the words mean. And when I'm trying to talk to him back, I probably do not sound terribly intelligent because I don't think about or use that same nomenclature. Because I know a lot about the eye, but I know a lot about the rodent eye. And we use different terms for the same structures than the human clinical community. Now, on the other side, I'm a basic scientist. And the reason I'm in this collaboration is that I am an expert in the gene that's mutated in the patients he treats. So I know a great deal about how this gene functions and how it works. And I can spew at him all sorts of my jargon in relationship to cell biology, cell signaling, molecular biology. But fundamentally, if we're going to have a good collaboration, we're going to have to communicate. And under that circumstance, that means that if I'm explaining something related to the function of the gene and how it could cause these diseases, I have to step back and think, this clinician, last time he had cell biology was when he was a second-year medical student. On the other side, and not treat the clinician like they're an idiot. On the other side, the clinician has to appreciate that I am not an ocular surgeon who's been doing ocular surgery for 20 years. And so he needs to step back and communicate and explain things to me in such a way that I understand. And so in the end, to have this collaboration work really is based on mutual respect. That I respect my collaborator a great deal. We're currently writing a patient information brochure on our disease. And that he wrote stuff in his jargon, and I'm sitting here redefining stuff because I can empathize with the patients we're reading to because I don't know all the medical jargon that he's using. But similarly, when I write my part, I'm going to try to tone down the cell biology, but he's going to have a much better idea of what that patient's not going to know or understand. So hopefully between the two of us, we're going to balance out and have something that's readable to the patient community. But in the end, it's the idea of empathy, is that develop a good idea of who you're communicating with knowledge base. Then we want to realize that they're unlikely to have that depth of expertise. And then remember what it's like to not understand something. And that is often a very, very hard thing for people to do. I work with graduate students a lot. I have a graduate student in my lab right now. He's only a couple years in the graduate school. But he's writing a document, and 2 years ago, he didn't understand any of the things he's talking about. And he has to communicate with somebody who doesn't understand this. But now he's internalized all the information. It's very hard for him to remember what it's like to not understand the topics. And it's a very hard skill to learn to be able to remember what it is not to know. Okay? But if this talk does anything, I want you to start at least trying to realize that this is something that you need to work on. And to always approach a writing task by trying to remember what it's like not to know. Because if the reader knew, you wouldn't be bothering to write for them. Okay? Now, the first step of this has to be identifying your audience. And if we're talking for a publication, that the first thing that you always have to do is step back and say, what are your most interesting, important findings? And to really be honest with yourself about who those findings are going to appeal to. we all love what we're doing. We all know that it's exciting, but you need to be able to objectively say who will care about this work fundamentally. And that will help you decide what kind of journal to submit to. Also, another place where you need to be very, very self-aware is, does the study meet the highest standards of rigor and proof? Now, we all aspire to our studies meeting the highest standards of rigor and proof. However, there's often a gap in our work. We have not connected all the dots. There might not be possible to connect all the dots because the study necessary to do that would be too expensive, too time-consuming. You need to publish where you are now if you're going to apply for the money to get what's going on to connect the dots. So you have to be able to, again, be able to be brutally self-aware to say, is that work really going to go to the top journal in the field, or does it have a limitation? For instance, in the study that I just published with my collaborator, that it was a retrospective case study. And retrospective case studies do not get the same place in the medical literature as case-controlled prospective studies. So we knew it was not going to get into JAMA Ophthalmology. But it was a valuable piece of work retrospectively because it puts it out there as this is a potential treatment for these patients. And it also then sets up the preliminary data to propose a prospective study. So sometimes you have to publish things that aren't perfect, but knowing where the audience is very helpful. Now, you also have to decide what audience would find these findings most important. And now, is this only interesting to a niche within a subfield? Could it be interesting to different audiences depending on how the study is couched? I'm in a field of eye research where we're relatively small compared to, let's say, cardiovascular research. There might only be about 10,000 people doing ocular research in the world. Other fields of science are much, much larger than that. Is the work only going to appeal for people in that group? Or have we found things that could be applicable to other fields? And often it's writing how you think of the significance that will change whether or not somebody sees it as being involved in a big picture. That what fields do you want to develop a reputation in? That often people will publish in the same journal over and over again, which tends to mean that only people who are interested in that journal read it. And they don't develop a broader reputation because people don't normally notice the work. Also, can you relate this findings to a bigger medical question beyond the initial study? For instance, in my field, I study ocular fibrosis. Now, some of our work is applicable to clinical issues in ocular fibrosis alone. Others of our work are important for fibrotic diseases throughout the entire body. And it's knowing whether or not we found something that could have an impact on the idea of fibrotic diseases beyond our local interest. And again, being self-aware and writing it in such a way to interest people outside of your local area. Okay. Now, profiling this audience is really important to have your paper be both accepted for publication and highly cited. And a lot of this is understanding who do you even need to appeal to when you're writing a paper. Because you need to know who those editors are. Because they're going to decide whether the paper even gets sent out for review in the journal you submitted it to. They're going to determine who the peer reviewers are, so who's really going to go through your paper with a fine-tooth comb. And also, they're going to be the ones who decide whether the paper is ultimately accepted if there's a difference of opinion in your reviewers. And this can be very, very different depending on who the journal is. Many, many high-profile journals are not actually edited by working scientists. These are professional editors. Very, very often, they're newly minted PhDs who really have not run a research laboratory on their own. And very high-profile journals such as Science and Nature use this format. So you're not trying to excite anybody who knows your field in depth at all. Somebody who has the basic credential in the field and that they are probably broadly interested in science. So that is the sexy factor. That is your work going to appeal to somebody like that or not? If not, it's not going to work at a journal like that. Now you also have working scientists in some journals that probably have zero knowledge in your field. And these have to do with many of the open access journals. I put PLOS 1 out there because it's probably the largest of the open access journals. So this is a case where I'm an editor on the editorial board of PLOS 1, and the people who send which papers to me have so little knowledge of the field that I have gotten asked to review, to deal with as a sub-editor, things that have zero to do with my expertise. That they're looking at this and separating it out. And under that circumstance, you know, to get it to even the right level of peer review, you have to really explain to that person what you're doing and why they should care about it. And then there is the journals such as Journal of Biological Chemistry, many of the society journals, especially many of the clinical society journals. For instance, Investigative Ophthalmology and Visual Sciences, I'm an associate editor there, and this is how we work. And this is our editor-in-chief knows broadly some about everything related to ocular biology. He then looks at that paper and he sends it to one of the associate editors that's closer to that area of expertise. The associate editor still might not know anything really about that subject, and then we pass it off to editorial board members that hopefully have more expertise, and sometimes we're wrong about that because we knew so little about the topic to start with. Now hopefully you're down to an editorial board member who is able to in fact identify expert reviewers in the field. But you have to have this be readable so it even filters down to the level of getting to the expert reviewer. So you do have to be able to explain things to a level to get it to the right people to be evaluating your work. Now, you also have to imagine these likely reviewers. What knowledge will they have, and what will be the beliefs about the topic of your paper? And this is in relationship to dogma. That if your work contradicts what people in the field believe, even if there's no evidence for it, you have an uphill battle. And you need to be able to write this in such a way to directly address that this is what people believe, show with evidence that nobody really has proven this, and that your paper has gone on to change what people feel about a certain subject. You also need to be thinking about what will they find exciting and interesting. Most people who are working scientists find what they're doing exciting, I hope. But that doesn't mean anybody else does. So you have to be able to step back and empathize about what the people who are likely to be field experts will find exciting. Now, one thing that I don't, how many people here are working research clinicians and scientists? We have a couple, so we don't have 3. So what I might do is skip this discussion sidebar then. But the thing that I want you to think about is, you know, when you're working on your science or when you're working on what you're working on, how do you explain this to your colleagues? How do you explain this to your next door neighbor? How do you explain this to your mother, assuming they're not in your field? There's different levels and different ways you would explain what you're doing, depending on what that audience is. And this is something that is helpful to think about as you go through and present for scientific writing. Okay, so the other thing, though, that people often fail to do is to imagine the readers. Now, the reason that imagining the readers is really important is that this will be directly related to the impact of your work on the broader field. Because you can get something through peer review, but if it's so dense and jargon-laden that people who could be peripherally interested cannot pick it up and understand it, your paper is unlikely to be cited and unlikely to have a broader impact on the profession. The thing to keep in mind about the readers, they have less background knowledge, and they also might be the direct members of what you might consider your interpretive community. One place that I'll just bring this up because it's somewhat of a pet peeve of mine, I do biomedical research, that almost everything I study is directly related to clinical conditions. However, I often find if I'm trying to read a clinical paper, they don't even define what the disease is. They launch into this very, very hyper-specific thing without spending 2 sentences at the beginning to lay out what they're studying or why. And that those 2 additional sentences will make this paper so much more accessible to, if you're a clinician, you're writing the paper because you want somebody to help you cure that disease. Make it accessible to the people who could help you do that, is, I guess, part of what I'm trying to say. Now, and this is, the other thing is that often, that especially for rare diseases, the patients are also going to be interested in reading your paper. Now, no, I'm not suggesting that you have to write it in a lay format, but again, explaining just certain terms can make a huge difference in the accessibility of your work to a larger patient base. And this is just something to keep in mind, is that no, these aren't going to be your reviewers, but a little bit difference in tone can make your work become more exciting. This can result in invitations to conferences, because very often there are disease-specific conferences where the patient advocacy groups are very involved in the organization of the scientific programs. This can give you access to a concentrated group of patients that you might be able to use for future studies. But if you can't communicate with the patients, those groups will not notice your work and will not invite you to those opportunities to be able to get more tied into both the funding community, the funding that these patient communities can provide, as well as the patient access themselves. Also, and I know I've just been picking on clinical papers, but basic science papers are equally bad, because that we have so much jargon in our field that even first and second year graduate students can't often understand scientific papers without a dictionary. And that, again, being aware of the need to define things, to not assume that everybody has memorized the importance of a certain signal transduction cascade, that can really, again, help the accessibility of your work to a broader audience. Maybe the clinician who has the disease that you're studying. So the problem is that if you don't strive to make your work accessible to a large group of readers, it might not even go out for a review if the editor who's gotten your paper to assign it doesn't understand it. And if it's reviewed, it might not be accepted because you haven't convinced those reviewers that your work is important or interesting. And if it's accepted and published, its impact's going to be minimized because the people who would use your information may not find the work, may not understand the importance of the work. Now, everything I've talked, though, about is about papers. One thing about when you submit a paper for publication, though, you almost always have robust opportunities for revision. If you fail to excite an editor, there's always another journal, and you can turn it around in a few days and get another chance. If it's not accepted, if the reviewers don't accept it immediately, often you have a lot of detailed comments that you can directly address, and you have that opportunity to go back and forth with those reviewers to improve the paper. However, this whole subject is even more important when you're looking at grants. And the reason is that funding rates for grants are seldom higher than 20%, and they can be below 5%. So under that circumstance, you're going for very, very limited resources. Everything you're competing with is almost always a project of importance, is almost always well designed, and the people who are producing or who are suggesting the work are equally accomplished to you. The National Institutes of Health has criteria for reviewing grants, and one of the criteria is investigator. It's on a 1 to 9 scale. The median score is a 2 for investigator. That's because everybody submitting are highly accomplished scientists. It's extraordinarily unusual to have an investigator score worse than a 3, and 1 being the best. So it's not a case where you're going to get a leg up because you have a lot of degrees or you have a position. So you have to differentiate yourself in another way. And the way you have to differentiate yourself is to excite those reviewers and decision makers about your work, to say that of the 100 things that are presented to them that are great science, that would be great to know the answers to, you're in the top 8 to 10 that are so important that we have to give them money. But the thing that probably is the most frustrating around grants is that you almost always have to get it right the first time. Many grant mechanisms, you send it in, you either get funded or not funded. That's it. And if you get feedback and you feel the feedback is wrong, unfair, you have no opportunity to address that feedback. Even from the National Institutes of Health, you do have one round where you can address that feedback. However, you're unlikely or often will not get back the same people to look at your grant again you're giving the feedback to. And it's a minimum of 9 months from the time you submit a grant, get the feedback back, and can send it back in. So that means also is that things are moving on, you're not funded, and you're very stressed out. So you really have to get this right the first time. So you also have to understand what your audience is for a grant application. There are so many kinds of grants, and the examples I'm going to give are either small private foundations or the NIH, because that's what I'm most familiar with. But depending on what you're looking at, you're going to get different things. Now, I think most people, when they write grants, are anticipating that they're going to have expert peer reviewers that are the direct members of their interpretive community. Thus, they don't have to explain anything because they should be able to get it, right? However, that is, if you're lucky, you'll get one of those people. Maybe 2, even at an NIH studies section where they really aspire for this. You will almost never get 3 of your reviewers who are absolute experts. And in fact, in the study sections that I've been to, usually grants, they try to give 2 experts and 1 person who is somewhat aware of the area but is not an expert, because that person can judge the broader significance to the field. Now, you also can have experts in subject matter that have no knowledge of the specific area. That's that 3rd reviewer that often happens from an NIH grant. And in this case, it might be an expert in wound healing is asked to review a grant on pancreatic cancer, because that pancreatic cancer might be through an epithelial to mesenchymal transition, and fibrosis is fibrosis, and signaling is signaling. But that person is not an expert on pancreatic cancer. So there has to be an ability to communicate with that person. Now, those are the reviewers you're normally going to get, let's say, from the NIH. However, for small foundations, the chances of you getting a subject matter expert are often pretty low, at least the small foundations that I have participated in their grant review processes. That in many cases, you're going to get the general subject matter expert. However, some foundations, you're not going to get a subject matter expert at all. And instead, you might get people who hold some kind of a terminal credential. That could be a terminal scientific degree or a medical degree. And they could lack all current knowledge because they haven't been working in science at all. Maybe that they're a senior administrator at DuPont. There's a couple foundations in Delaware that do science grants, where the reviewers are these senior administrators. They used to be senior administrators at DuPont, where DuPont imploded. And they will look at your grant and they will have absolutely no idea. And these are people who might have gotten their PhDs before we knew the structure of DNA, okay? And I'm not kidding about this, especially 20 years ago when I was starting here in Delaware. You also can have people with medical credentials that lack interest in that area of study. these are often friends of donor families. So you have somebody who's interested in the disease, they have a lot of money, they're setting up a foundation, they need to have experts. Well, experts are the physicians they happen to know, but they might not be subject matter experts in that exact field. But they're going to be asked to do the review because they're trusted advisors of the donors. And then another group are the patient advocates, because for many of these medical scientific foundations that I'm aware of, the primary review, they try to get subject matter experts or other experts, but what decides whether the grant is funded or not depends on whether it fits the interests of the donor. And in patient advocacy situations, that's usually somebody who's really interested in a cure. And these people often know a huge amount about the disease of interest, but they probably lack a deeper scientific education. Now, there are a lot of resources out there, but do the very best you can to figure out who that audience is. Because writing to appeal to a patient advocate is going to be a very, very different thing than writing to appeal to a scientist who knows the details of the topic. And the National Institutes of Health has some great information on this. Other grant mechanisms, you can probably figure it out from the patient websites. For instance, many of the Department of Defense congressionally mandated areas, those are subject matter experts and patient advocates are sitting on the same panel. So there are grants that are judged very, very good science that aren't funded because they have not convinced the patient advocate that this work is going to deal with the diagnosis, treatment, or prevention of the disease. You can also ask around the community and see if find out if anybody's ever reviewed through that grant mechanism. That can be a really helpful way to get insight. Also, you can always pick up the phone and call them to say, just want to know who am I writing this grant to. They may or may not tell you, but at least if you get a general idea of the type of person who's going to be making the funding decision. Now, from the standpoint of every single one of these reviewers has strengths and weaknesses from your perspective as a writer. The expert reviewer is going to know all the literature in the area, backwards and forwards. So they're going to notice when you make a mistake. And particularly if you're coming into an area that you're not 100% familiar with, they're going to pick up every single comment you make that is naive and call you on it. Also, these are the folks who are going to have accepted the dogma in the field. And you need to convince them why they need to reevaluate what they believe to be true, okay? And they're also going to really know whether your experiments are feasible or you sound naive. For instance, in my field, there are certain experiments that one can propose in theory, but you can't do them because you can't get enough cells, you can't get enough patients, you can't get enough of something. And the expert reviewer is going to notice that and call you on it. However, so this can make an expert reviewer really tough, but they're also already convinced that what you're studying is interesting and important. So you may need to spend less of your space really explaining the significance of the field or the applicability of what you're doing. But you also have to keep in mind that you're also likely to get peripheral experts. And I always consider peripheral experts of those folks who know enough to be dangerous. Mm-hmm. And I'll use an example from my prior life. There's a cell biological concept called the unfolded protein response. And I submitted a grant to the NIH that was on this topic in the ocular lens. But it turns out that there's also something in the ocular lens where cataract is caused by unfolded protein. So while no one had looked at my cell biological mechanism, there's 40 years of literature on the role of unfolded protein in cataract. The two topics have little to nothing to do with each other. However, I got a peripheral expert who got annoyed when I said that nobody has ever studied the unfolded protein response in the lens, which was absolutely true. But the person didn't know enough to know that there was a cell biological mechanism, and they knew just enough to know that that's a major causative mechanism of cataracts. So this is something that you try to envision these problems, and I actually had envisioned this problem, but I didn't, the person had already gotten their mindset before they got to my explanation about why these topics were different. So I was lost in that grant review cycle. They also, the peripheral expert may not see your problem as important because maybe the question is answered in the direct field of study. This is a really big problem in biology because there's a lot of genes and proteins that have completely different multiple functions in different places. So somebody might say, it's known what this protein does in this place at this time in, let's say, the heart. But that protein could be doing something extraordinarily different in the retina. But if somebody feels that the subject is dead, done, and not interesting, they're not going to be open to you investigating what this is doing in another situation. So you have to convince them it's likely to be different and why. They also might not appreciate the limitations of your experimental system or study population. This could be a case of power. If you are studying a very rare condition where there's only 50,000 people in the world, and they're asking you, and the reviewer thinks you should be doing a study that requires 200,000 people to do the GWAS analysis, well, you know, they know the subject, but they don't know the limitations of your study population. This can also be an issue if you're studying cell biology, is that if you are really interested in a tissue in vivo and you can only get 20,000 cells, but the reviewer feels you should be doing a technique that needs 1 million cells, it's again, they don't know enough to know what they're thinking isn't reasonable. But they're also unlikely to catch errors, or some of the errors, because they're unfamiliar with the field. So they don't catch that naivete, because they don't know either. And they also could find your study exceptionally cool if they have learned something new. And I have actually run into this, that this can be a huge advantage, because I study the ocular lens. It's transparent and has cells. And there's a lot of scientists that don't know it's made out of cells. And they find this out and they're like, oh, that is so cool. And then everything you say is brilliant, even though it's been done for 50 years. And so sometimes there can be an advantage under that circumstance. And then we have the ignorant expert. The ignorant expert is somebody who has formal training in science or medicine. They don't have any training in your area at all. This can be a DuPont chemist reviewing your transgenic mouse experiments, or the training is decades old. So the last time they saw the subject was 40 years ago in a sophomore level course. Now, like I said, these are very common in foundation grant reviews, but they're chosen because of the donor's friends or they're experts in the administration of grants. These are people that, you know, sometimes it's a crapshoot, but often it's looking for the things that are the most generally interesting to make sure you at least bring up so that the person can start understanding what's going on, even if they don't understand it at the end. And then the patient advocate. These are people who are self-educated on the science needed to understand the disease. They are often extraordinarily passionate about the subject because either they're affected by the disease or they have close friends or relatives that are. They can have read pretty much every paper out there on the topic. But also though, it's a lot of patient advocates are only fundamentally interested in investigations that directly lead to diagnosis, cure, or prevention of the disease. So you have to make that connection explicitly. Your science might be deep mechanistic insights into something, but you need to explain how knowing those deep mechanistic insights will allow us to design that cure or figure out how to diagnose something early. And you need to explain this in a way that's very accessible and very convincing. And this is not the kind of thing if you send an NIH grant, you have to talk about biomedical relevance. We all write, this investigation is going to cure the condition. But We also know that most of it is basic science. NIH funds more basic science than they fund direct clinical work. So people don't really pay that much attention to it. In this case, for these kinds of foundations, you need to be explicit and direct about it. And that's the reason that there are the Department of Defense congressionally mandated mechanisms, is because patient advocates felt NIH was not responsive to this subject. Okay. Now, the thing that I want to emphasize, though, is that your reviewers are likely to be a mixture of all of these populations. Like I said, for the NIH, your application is assigned to the study section. Most of the scientific review administrators at NIH I know go for 2 expert reviewers and 1 peripheral expert review. And there's not even a guarantee you're going to get those, though, because sometimes you just have a grant that's so out there, it has to be read by somebody, it has to be reviewed, and they just can't get a subject matter expert. And you have to appreciate that the people who know your science best, maybe they're in a foreign country, maybe they're just busy, maybe that their funding is in jeopardy, so they're not going to review for the NIH at that moment. You also have the second round of review for the NIH, that is the Board of Scientific Counselors. For other foundations like the Fight for Sight Foundation, which I'm very involved in their situation, is that the primary review is this group of experts. The secondary review is a board of donors, patient advocates, and senior corporate leaders. And they're deciding what of the studies that are considered meritorious scientifically or more likely to lead to cure for a blinding disease. And those grants get huge preference over basic science investigations for these patient or disease-specific foundations. So I think the thing you have to realize is the funded grants have strong scores for science and have convinced that board that they address the focus of the foundation well. This also can really matter at the NIH, because there was a situation a few years ago where there was a study section panel. Everybody who is an expert in herpes virus infections of the eye had their grants in that panel. So there were 20, out of 100 grants, there were 20 grants in that field. They were all the top experts, and something like 15 of those grants ended up within the normal funding line. However, they could not fund only herpes virus grants in the eye for that round at NIH. So there were herpes virus grants that got really great scores that did not get funded because they couldn't give all of the available funding to a small subsection of all the research that NIH supports. And that's something you also have to keep in mind, is that it's not just about your score, it's not just about your great science, it's about how does it fit the larger picture. Now, what I always want to talk about for the last few minutes is sort of a wrap-up, but also how to apply this information a little bit. Everything I've really focused on has to do with knowing your audience, and that's understanding what your audience brings to the table in regard to background and knowledge. If you do not understand your audience, you're not going to give them the information necessary to evaluate your work, understand it, or utilize it. And that is incredibly important if you're going to have your work make the broadest impact. In a very simple way, this could also be writing your science in a way that a pay-for-operation brochure, but it also could be making sure that somebody who doesn't know anything about biology can at least understand the first paragraph of your grant application, which is, if you don't do this, they're like, I have no idea even what the topic of this is. Trash, not funded. You can't afford to do that. Also, to understand what motivates your audience. The goal is to make them excited. For the patient advocate, it's going to be the potential for your investigation to help cure or address the disease. For the basic scientist, it might be there's this really interesting unanswered problem that maybe this experiment will get at it. For the clinician, it might be a new way to treat a patient that you no longer have to say to them that I can't do anything for you, okay? But to address and make it clear which one of those things, make it clear to the audience that that is the potential here. Now, another thing though is that once you know your audience, you need to know how to communicate with them. And a big feature here is you have to be explicit. Don't be afraid to state the obvious. This is probably the biggest problem I see in student writing, especially grad student writing, is that they say that, oh, I'm going to do this, this, and this, but they never say what that will tell them. They feel that putting the information there without putting it into a framework and explaining step by step how it works, that I can see how all that fits together in my head. Of course, the audience will be. The thing about that is that that knowledge and that understanding came from months, years, and in some cases decades for those of us who've been around a while. We can see how it all fits together by just seeing some facts. That does not mean that somebody who's naive to the subject will be able to see any connections at all. And this is one thing that's really, really critical, especially if you're thinking of a grant or a paper, is that you have done these experiments, you have lined up the evidence for a conclusion. And try to remember how hard it was to see how all that fit together. Because what happens very often is that people will put that information out there, give a conclusion, and nobody can see how that was done. In a situation of a grant, that what often happens is that the expert reviewer will see the same evidence, haven't really thought it through a lot, and will come to a completely different conclusion from that pieces of evidence, because you haven't clearly explained all the steps of the logical reasoning to get there. So it is really, really dangerous in your writing to provide people with a lot of information without any pathway about what it means, because they're likely to come to a different conclusion, and if that's a grant, they're not going to fund you. And this is part of providing the linear narrative that makes logical connections between pieces of information. That don't give them a cloud, say that this means this, means this, means this. It could be the reader will not agree with you, but if you don't provide that linear path, they're going to find their own, and it might not be yours, and then you're not funded. Okay? And fundamentally, it's not reasonable to even have the top experts in the field be able to quickly assemble a narrative while you've spent years on it. And the thing to keep in mind is that a paper reviewer or a grant reviewer, if you're lucky, they spend an afternoon on it. Very often, they spend an hour on it, because grant reviews, paper reviews, those are the last things at the end of the day. You're tired, you put the kids to bed, it's like the people at the study section say, oh, all your reviews are due in 5 days. You're like, crap, I have 11 to review. And you have to shoehorn that into the subject. And if you don't, if something's not easy for you, you don't have the time to do the heavy lifting to make the connections if it's not laid out for you. Okay? Now, the other thing that's kind of similar to this is the idea of providing information just in time. There's a very strong tendency that people think about this very, very separate. They will write all of the introduction you need to understand the entire study or to understand the entire grant. And they'll do this in a few minutes. And then they'll talk about everything else downstream without referring to that information, expecting you to be making that connection. The problem is, one, is that when's the last time you had an unfamiliar topic introduced to you? It was introduced to you in 5 or 10 minutes, and then an hour later you were able to understand that. It's very, very unlikely. Practically, like when you're reviewing a grant, very often you won't even be able to sit and read the whole thing at a sitting. So the reviewer read this introduction, and then later that day, they'll read the body of the grant, and they forget that the preliminary data is up here, that the experiments are up here, that the justification's up here, and that they don't remember what you said well enough to be able to apply that information to understand the complicated problem. And then the other thing that to remember is that if you are somebody who can hear information, very complicated information once, and then a few hours later apply that to a complicated problem, I assure you most of us can't. At least I can't. And so what you don't want to do is front load the information. That you want a general introduction that basically says this is why it's important, this is why we need to know. But the direct justification for proposing that experiment or for doing that experiment in a grant has to be presented proximally to the experiment. It's again part of walking your audience through it. It's the same kind of thing if you go to a seminar, somebody gives you this dense introduction and then shows you data slide, data slide, data slide, data slide, data slide, and then at the end gives you this huge conclusion. You have no ability to be able to follow that narrative. But if there's a big picture introduction, then there's an introduction to how this is the problem, this is how I'm going to address the problem. Here's a piece of data. This data told us X and Y, and since we know Z, which we've just presented, we did this experiment. And you continue to do that through the talk. It's a lot more accessible as a talk. It's also a lot more accessible as a grant application as well as a paper. So basically how I try to explain this to students is you don't want to front load too much information in your writing. You want to provide the information when it's needed by the reader to be able to understand your logical flow. And then at the very, very end, the last thing I want to say is to make sure you always focus on the big picture. And that comes from, if you're working on a study, you learn to care very deeply about the details of why that result was obtained. And as an example, why does my mutant mouse have a phenotype? And you can put a lot of emphasis on that, and that will become the most important part of your world. But to be perfectly honest, it's unlikely anybody else cares why your mutant mouse has a phenotype. What they might care about, though, is that, maybe what they care about is what is the function of that gene. They may care about what is the function of that organ. They may care about that disease. But they're not going to care why that specific sub-result happened, because that was the experiment, that was the data. But you have to relate that back to the big picture of the scientific problem you're trying to address. And this is probably the other big thing that I see, particularly among student writers, is that they get so, one of my students is doing a budget justification right now, and he's like saying, we're going to buy this to do this experiment. Yes, but it might be more compelling for them to give you money if you say, I'm buying this because I want to solve this problem related to the disease. And it's not a big difference, but it can be a huge difference emotionally and psychologically to the reader. And with that, I'm going to end. I think I've gone my time here.
Well, that was fantastic, and certainly caught my attention, and it's stuff I think about all the time. And for the young people in the audience who are listening to this, they think, "My God, this sounds really hard." Well, it is. Right. It's very hard. But I'm going to make a couple of comments, and I'll see if you can agree or disagree. Okay. But I suspect you can agree. It gets better. It gets better over time. It takes a very long time to learn how to do this. So I would say it takes 15 years to learn how to write a paper and 30 years to learn how to write a grant. So a friend of mine, very eminent scientist from McMaster University, very, very successful, said to me, I guess about 2 years ago when he was 65 years old, he said, I finally learned how to write a grant. So this is someone who's really successful, who's written some of, tremendous grants, who's had tremendous fundings over the years. So it's hard. The other thing I would stress is the importance of understanding all this in mentoring. As a mentor, what I tried to do for years is understand what my mentees are saying. that doesn't help them adequately. Yes, you have to do that. But what you got to get your mentees to understand is that they don't have to get the mentor to understand, they have to get the audience to understand. So the mentors have to instruct their mentees on how to get there, which is a very, very difficult thing to do, because you still have that process that it takes so long to learn how to do this well.
Yeah, I would agree that I think it at least takes a minimum of 10 papers before you start to feel comfortable writing a paper. I think from the standpoint of really being able to step back and see what your audience is, that sometimes it depends on the person. Like we have a assistant professor in our department who seems to have understood this instantly and immediately. While it takes other people a much harder time. And I know I've got this, it's taken me more years to get to the point of seeing how to really sell your work to the broadest possible audience. I think I've only been decent at it in the past 5 years or so. And I still try to sometimes run stuff by people who I think are much better at it. Because that while you try to get out of your own head, if you're personally excited about your work, it's really, really hard to be able to figure out what other people are thinking and how they may perceive what you're doing. Yeah, I would agree with everything that you said. And it's an issue with mentoring. It's also an issue with just learning how to do it yourself.
How do you decide, or how do you evaluate in a study section, so when we try to submit grants for NIH, the experts in your field, and you don't really know who is going to be, you don't know at all actually, who is going to be assigned to your grant. So,
well, one thing, going to conferences definitely helps. For NIH, you often have an idea of who the pool is likely to include. So you can get the rosters on the study section, and you'll at least see what the pool is likely to include, who's permanent members. And now you don't even know if that permanent member is going to be on that study section, because they're only on 2 study sections at 3 now. But that's one way. You never know who's going to come in and ad hoc. But it's also, I think, kind of important to be out there and make sure you go to the conferences in your field, because you can often get some pre-ideas about what people are feeling about your work, how your work's being perceived. When you go to if you're giving a poster, what are the questions you're getting at that poster session? If you're giving a talk, what kind of questions are people asking? And you know, some of it is just imagination, and sometimes you're wrong. I mean,
yeah.
You will be wrong sometimes. And just recently I ran right into being wrong. It's that there's a reagent that's used in my field that is pretty much now getting discredited as being used. And just trying to, and we had this last investigation using this reagent that has some issues. And you know, trying to get that work published. And different reviewers responded to it extraordinarily differently. Some people thought it was the best thing ever. And other people were like, well, because that reagent is a little iffy, we can't trust anything that you get out of that experiment. And then other people were in the middle. I'm kind of in the middle on this. Like if I get a paper using this reagent to review, I'm fine with it going forward as long as all the caveats of the interpretations are given. And you don't know. I mean, when you, after a couple journals, I got it accepted. But you just don't know until you see the reviewers you got, because you don't have control over that. And you can't, and it could just be, even if the reviewers that you think you're going to get invited, maybe they're at a conference. Maybe they're ill. Maybe they're going whitewater rafting down the Grand Canyon and they're not available. So you'll get who you get, and you have to deal with the reviewers you get. You know, there's no certainties in this process. The only certainty is that you have to at least make the attempt. Because hopefully communicating to who's out there, even if you're wrong of who's reading it, will at least still be effective for another audience. I think it's the best thing I can say. Yeah.
So I'm going to make a couple of comments. One, so failing on any one thing isn't so very important. Especially when you're young, you get a review back on a paper, it's just got cream, and you feel like it's the end of the world. It's not. And so as best you can, do not react emotionally. Pick yourself up. Go back to work. Respond to the reviews. Send it over to the next journal. Whatever. And over time, you stop reacting emotionally as much, and you get used to it. At least I do. I got better.
I still put my papers in the drawer for 2 weeks.
I'm not perfect, but I've gotten better at not reacting.
But I think the key is that you can't just leave it in the drawer forever. There's a lot of people who you get bad reviews and you leave it in the drawer forever. And it's never seen light.
So you definitely don't want to do that. Persistence is really important. And what I always say is keep going. And if you send in a grant and it's crap, you get back reviews that say it's crap, and say, this stuff was wrong. This was really crap. And you go and you move on. The other thing, learning how to do this is extremely important. As you go on, you get more and more opportunities. Is to review yourself. So review a lot. Try not to turn down opportunities to review. Do not turn down opportunities to be on editorial boards, or even better, associate editor or an editor. But the best of all is to sit on an NIH study section.
Oh, absolutely.
There's no training ground like that. You sit there, and there's a bad grant, and they sit around and they laugh at it. And boy, do you learn from that experience.
Well, now that most of those don't ever get discussed.
Right.
That there was one, though, that I was on one of those special study sections where everything gets reviewed, and there was one that was just a really bad grant, and that was nice. Because it was from a really top guy in the field who wrote a crappy grant. But I would agree with everything you said. Is that, but I think the biggest thing is it's really hard to be self-critical, and you have to basically learn how to be self-critical.
Good. Thank you so
Thanks so
much.
much.